So one more type of problems are navigation. So in navigation, a direction is often given as what we call a bearing. And a bearing is just an acute angle measured from due north or due south. So let's see what we mean by that. So if you look at this is a bearing of 30 degrees and it's north 30 degrees east. Okay, so it's the angle measured from due north. So it's this angle that it makes with the north axis or whatever we want to call it. So this 60 degrees angle right here is north 60 degrees west. So you see north comes first. Now if you have south bearing, so this one is the angle that it makes with the south axis. So this angle would be south 70 degrees west. And this angle here will be south 50 degrees east. Okay? So if you have a port with a ship right here, and they say that the ship travels south 70 degrees west, that's where it's going. Or if it says that it goes southwest 70 degrees, it means that this is the direction of the ship. All right, so let's see a couple of problems. So we have that an aircraft takes off of a runway. This is just the name of the runway to left. So you have the runway right here, which has a bearing of north 20 degrees east. So I have my plane or aircraft right here in the origin, and it goes north 20 degrees east. So basically north 20 degrees east is this direction, and this is the bearing. So this is north 20 degrees east. All right, after flying for 1 mile, the pilot of the aircraft requests permission to turn 90 degrees and head towards the northwest. So basically what we have now is that, okay, so this aircraft flies for 1 mile, so this distance right here is 1 mile, and then it requests for permission to head northwest. So it changes direction this way, and then it travels 2 miles this direction. Okay, so this right here is 1 mile, and this right here is 2 miles. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft? So basically what we're asking is like, what is the new bearing now? So we're asking, the aircraft is here now. So basically we want to know what bearing does it have now? So what angle does it make with the north axis? So this is what we're asked. We're asked, what is theta? Theta is what? What bearing should the control use to locate the aircraft? Okay, so as you notice, we have a right triangle here. So we can draw it like on the side. So I have that this is, I kind of flipped it a little bit. So this is 1 mile. This is 2 miles. And then this angle right here, it's not just theta, it's theta plus the 20 degrees. So this angle right here is theta plus 20 degrees. All right, because I'm having this red portion, but I also have this green portion that was the 20 degrees. So in our right triangle, we have to solve for theta now. So what trig function involves this angle, adjacent, and opposite? Well, tangent, right? So I have that tangent of theta. Actually, we're applying the arctangent. So theta plus 20 degrees equals arctan of the opposite. The opposite is 2 miles divided by the adjacent, which is 1 mile. So theta plus 20 degrees equals arctan of 2. And arctan of 2 is just a number, so since we're solving for theta, I'm going to subtract 20. So it's going to be arctan of 2 minus 20 degrees. Arctan of 2. Alright, so let's put arctan of 2 in the calculator. Again, if this was just a exam, this is what you would leave as the answer, but in the homework you can use a calculator. So you would put in arctan of 2. So I will do, you turn on your calculator, arctan of 2. That's 63.43 degrees. And then I subtract the 20 degrees. 43.44. So arctan of 2 is 63.43 minus 20 degrees. So this is degrees as well. So that gives us that theta equals 43.43 degrees. Okay, so theta, again, theta equals 43.43 degrees, and the bearing now is, well, notice it's northwest. So we would say it's north 43.43 west. So this will be the answer. Okay, so when we read this type of problem, our goal is to draw the right triangle that is going to help us find the answer. All right, let's solve another type of this problem. So this is going to be a homework problem that you have. So it's one of these problems. So you have that a ship leaves port at noon and has a bearing of southwest 23 degrees. And the ship sails at 25 knots. So how do you start? So this is a homework problem that you guys are gonna have. My pen is, so this is north, west, south, east, and the bearing for our ship. So the ship starts here and it was going, I already forgot, southwest 23 degrees. So it's going this way, and this angle right here is 23 degrees. So south 23 degrees west, and it travels at 25 knots. So this is just nautical miles. It's just a little more than a regular mile. All right, then how many nautical miles south and how many nautical miles west will the ship have traveled by 6 p.m.? So this right here is 12 at noon. So 12 p.m. So let's say that at 6 p.m. is right here. So how many hours does it travel? 6. Okay, so if it travels 20 knots, so 25 nautical miles per hour, after 6 hours, you will have 6 times 25, which is 150 nautical miles. Okay, so that means that this distance, this is the ship leaving port with this bearing at 6 p.m. is here. So this distance is 150 miles. Okay, and the question is how many nautical miles south and how many nautical miles west. So basically I'm interested to find this, like this is how many nautical miles south it traveled. So if it, so this, let's call this y, and how many nautical miles west it traveled, this is x. So we need to find x and we need to find y. So x is the number of nautical miles traveled west, and y is the number of nautical miles traveled south. Okay, so there you go. You recognize that we have a right triangle, and I have that the hypotenuse is 150. I know that the angle is 23, so if I need to find x, that means I need to think of a trig function that involves opposite and hypotenuse. So obviously that's sine. So if I do sine of 23 degrees, I get that it's opposite, which is my x, over the hypotenuse is it's 150. So then if I solve for x in here, x is going to be 150 times sine of 23 degrees. And when you put 150 times sine of 23 degrees in your calculator, you get 58.61. 58.61. So that is my x right here. And similarly for y, I'm going to have to think of a trig function that involves adjacent, since y is the side adjacent to the 23 degree angle, and hypotenuse. So that is cosine. Cosine of 23 degrees equals adjacent, which is y over hypotenuse. So then if you solve for y, you get that y is 150 times cosine of 23 degrees. And when you put that in the calculator, you get 138.08. 138.08. So that is my y. Okay, so I found that y is that. Okay, now the next question in this problem, it says that at 6 p.m. the ship changes course to due west, and then find the ship's bearing and distance from port at 7 p.m. So guys, at 6, this is where my ship is. So let's, at 6, and then it changes course due west. So it means it starts going exactly just west. Okay, so then at 7 p.m. the ship, let's say, will be here. So the ship right now makes a new bearing with the port. So this will be the new bearing with the port. And then the distance from the port will be this distance right here, right? So this is what we're asked to find now. Find the ship's new bearing and find the distance of the ship from the port. So now if we find this angle, let's call it theta, that's the new bearing. So it's going to be a southwest bearing again. And then we need to find this D. So now we're going to have to find another right triangle that we work with. So it's this bigger one now. So the right triangle I'm working with now, it's going to be this one. Which is nice because I know this side. But do I know this side now? So this y, we just found that this y was 138.08. And we know that this x is 58.61. I'm sorry, my pen is not working properly. 58.61. So in this big right triangle, I have that this side is 58.61 and this side is 138.08. But do I know how much is this distance? Oh yes, I know, because from 6 to 7, that's 1 hour. And I know that the ship travels 25 knots per hour. So if I add 25 to my x, that's going to give me this distance that I need. So let's draw this again. This is the big right triangle. And this is theta. This one is my y, which was 138.08. And this side right now is going to be 58.61 plus an additional 25 knots that it travels in that extra hour. So it will be 3, keep 1, 7, 83.61. So this is 83.61. And then I need to find this distance. So the problem now is I need to find, so this is east, west, north, south. So I need to find d and theta. All right, well, to find theta, I notice that I know the opposite and the adjacent, so I need to apply arctan. So theta equals arctan of the opposite side, which is 83.61 over 138.08. So when we put that in the calculator, so it's going to be arctan of 83.61 divided by 138.08 and 31.2. So it's 31.2 degrees. So the new bearing is south 31.2 degrees west. Okay, now that I have the angle, so now that I know this angle theta is 31.2, to find the distance of the ship from the port at 7 p.m., I just need to apply a trig function that involves this angle and either one of the sides. So let's pick this. Let's do sine. Sine of 31.2 degrees is going to be the opposite, which is 83.61, over the hypotenuse, which we call d. And we need to solve for d. So d equals 83.61 divided by sine of 31.2. Okay, so we're going to put that in the calculator and that will be it. So when you put this in the calculator, you get 161.4. All right, so that's how far 161.4 nautical miles is this ship from the port at 7 p.m. Okay, so as you have noticed, all of these word problems, basically your task is to translate them into a right triangle that you can solve. One more comment in the homework. When you have, let's see. Sorry. Okay, so if you have problems like that, where this angle beta right here, this beta, if this angle right here is beta, this angle right here is also going to be beta. If this angle right here is theta, this angle right here is also going to be theta. So that's going to come in handy when you try to solve these problems. So if you have an angle beta right here, this angle down here, I don't know if you can see this, this angle down here is also going to be beta, the theta.